Hello, my name is Raul Cuevas, and this is my project for Chem 2101 Molecular Modeling. In this video, I will show methods of obtaining theoretical values for different colors of different fullerene compounds using AMPAC. I will do calculations for C60 and 3C60 molecules with different groups attached to it. First, we start by drawing C60 on the builder, and then we go to right-click, calculate, AMPAC calculation setup to start optimizing the molecule. We leave the job type on optimization, we go to method, change the model type to PM3, and we leave it on restrict to HF on wave function. Later we submit the job to AMPAC, and it asks us to save the file, and we choose a name to it and save it. I already have a file saved with optimization of C60, so all I need to do is open it from AMPAC, and after doing that we can close this one, and this would be our fully optimized molecule. Later we need to go to calculate, AMPAC calculation setup again, go to job type and change that to energy. After that we leave this on PM3, or wing function we change it to CI, and CI method to singles, max configuration to all, bracket Fermi level we change this number to 60, and finally we change the number of final eigenstates to 100. This will allow us to submit and save the file again. Name the file how we want to, save it. It tells me that to overwrite it, and we submit the job to AMPAC. This will give us the UV spectrum of the molecule, and with that we will be able to calculate the color of it. After the program finishes calculating, it's gonna give us 3 files, and the one we need is the output file. So we click OK, it opens the output file, and once it is open we can come to results and then UV-Vis, and it gives us the UV-Vis spectrum of C60. After that we can go to properties, and here in UV-Vis peak half width we can change it to 500, and that will reduce the width of the peak, giving us a better peak to look at. Later we can go to save data, and initial frequency we can select it to 360 and final to 780, step size to 1. This will give us the visible spectrum of this molecule and aid us in obtaining the color of it. It tells us it already exists because I already have it, and then after doing this we can go to file and start a new one. After opening a new file, we can start a new calculation with another molecule, so we can have all the data for all the molecules. This is the molecule that I'm gonna do next. It's already drawn, and all we need to do is optimize it again. Go to optimization, PM3, RHF. We submit it, and we OK, and it should be sent to AMPAC right now. After the calculations are done, we have to choose one of the 3 files again. So we open the output file, and this is going to be our fully optimized molecule. Later we go back to calculate, AMPAC calculation setup, we change to energy again, PM3, CI, singles, all, 60 and 100. Later we submit it again, we save it, we choose a name to it, we save it, we overwrite the file that I already have, we click OK, and we send to AMPAC to calculate for our colors. After our calculations are complete, we get the same 3 files, and we open the output file. Later, we go to results, UV-Vis, and we do the same thing as the last time. We change our peak width to 500, then save data. We choose the visible light range, which is from 360 to 780, and our step size of 1. I overwrite this file, and we start again with the next molecule. So now I'm gonna open a file of our third molecule. It's gonna be a C60 with a benzenamine group attached to it. We're pretty much gonna do the same as the other ones. Optimize it using PM3 and restrictory Hartree fog. We submit it. After a molecule has been optimized, we open the output file, and this is our fully optimized molecule. Then we go to calculate again, calculation setup, PM3, but now we change it to energy, CI, singles, all, 60 and 100. And we submit our calculations again, we save it, we select a name that we want to name it, override it, and we wait for the results. Once our calculations are complete, we open the output file and we check out our UV-Vis spectrum. We go to properties, shorten the peak width to 500, and we saved our data. This is benzenamine. We name it and save it. Mine has to be overwritten, and we are done with benzenamine. So now we start working with our final molecule, which is PCBMC60, which looks like this. And first we need to optimize it like we have done with all the other ones. Model of PM3 RHF, optimization, save. We select the directory we wanted to send it to, we name it, and then save it, override, and we send the instructions to AMPAC. After our optimization is done, we open the output file and we set up the next calculation to obtain the visible spectrum. We changed everything to the parameters needed. Energy, submit, we save, we name, and override, and we wait for the calculations to finish. Once our calculation is done, we open our output file, go to results, UV-Vis, then we go to properties, shorten our wavelength to 500, save data, give the range of visible light 360 to 780, and a step size of 1. Then we come to PCMB and overwrite our file. After this, we're ready to start calculating our color changes from each of our individual molecules. At this time, we have finished optimizing and calculating the UV visible light of our compounds. So now we need to use Excel to translate the information given by AMPAC into colors. We would need one spreadsheet that was provided by us during class with from our professors, and the information that was given by us by AMPAC and our calculations. One easy way to do this is to select all of the information that was given to us by AMPAC, open a new Excel sheet, and go to paste, use text import wizard. It will arrange all of our data into columns and rows next 3 times, and finish. Later, we need to delete one column, the first column, and the 2 rows that are the way top. Then we copy the first 3 rows, which will be exactly these 3 rows, and we paste. After that, we will get all the calculations done, and we change tabs to XYZ to RGB conversion matrix. Here, we will have displayed our 3 RGB colors. We will click a random cell, go to the theme colors, choose more colors, and here we can input the colors given to us into an RGB setup. So if we do that, we have 255, 249, and 244. Click OK, and it tells us that at a concentration of 0.0001, we have a white color. Later, if we come here, we can test if the concentration would change our color. So let's try a concentration of 0.0003. We change the 1 to a 3, and we come and see. Now we select the box under it, more colors, 255, 249, and 244. This gives us also a white color. So this pretty much tells us that C60 under a concentration of 0.0001 and 0.0003 has a white color. So now we go to save as. We go to the directory in which everything is, which select C60, and we rename it C60 color. And after this, we save it. So now let's try our second compound, which is C60 with an acetyl group. We open the file given by Ampact, select all that it's in there, copy it, paste it in a new file using the text import, next 3 times, and finish. Replace, delete 1 column and 2 rows. That's not possible, so delete 1 column and 2 rows. Copy 3 columns and come back to our Excel sheet and paste it. So now we change the concentration to 0.001 to be a little higher. So we come here, change this, and go to more color, custom, 255, 251, and 163. And now we see we have a little yellow using these 3 RGB colors. So now let's change our concentration to 0.008. We come over here, change our concentration to 8, and see what color we get. Go to custom, 255, 251, and 0. So it gives us a bright yellow. So now we see that we have a color change by adding an acetyl group. It changes from white to yellow. So now we save as, and our acetyl. So now we change our name from C60 to acetyl, and we save it. Continue. So now that we finish with the acetyl group, We go back to the user spectrum. We open the benzinamine file, copy it. We go to a new Excel sheet. We paste using text import wizard next 3 times. And just as before, we delete the first column and the 2 top rows. Copy column A, B, and C and paste it. Now we have a concentration of 0.008, so we change it to 1. Come here and compare colors. Go to more colors, 255, 251, and 160. Now we see the color was slightly changed, but pretty much remained the same. So if we augment our concentration to 0.008, we can see we lost the blue color and should give us a new color. And it's pretty much the same color as the acetyl group. 255, 251, and 0. So we save this. We go to benzinamine and rename it benzinamine. And this pretty much tells us that benzinamine, having a functional group of benzinamine and or an acetyl group, pretty much will yield the same color when attached to C60. Now lastly, we're going to compare the color of PCMB. So we open the file given to us by AMPEC, select it all, copy. We go to a new file, we text import next 3 times and finish. Now lastly, delete the first column and the first 2 rows. Copy columns A, B, and C. Paste it, and we change our concentration back to 0.001. Go to our conversion, and we see that the color might change drastically. So we import 106, 240, and 24. So now we see a kind of greenish color. And finally, we change our concentration to 0.008, and it has pure green. So we can conclude that by changing our concentration, it gets greener, and it's pretty much the only compound that changes to green color. So now, as we finish our calculations for PCBM, we can conclude that C60 remains white, while attaching an acetyl group to C60 or a benzinamine group will change the color of our compound to yellowish. And by obtaining a PCBM on C60, we conclude that our compound changed to green color. This has been the method used by the class 2101 molecular modeling to obtain theoretical values for colors for certain compounds using AMPEC.